talk about easy things to do. Scientific notation is super easy if you can count. Can everybody count? We're all capable of counting. Scientific notation is finding a way to represent something as a number that's between 1 and 9. In other words, it's greater than 0 but less than 10. So between 1 and 9 in front of the decimal point, and a power of 10. 10 to the first, 10 to the second, 10 to the third. Okay? So when you do that, you're multiplying by 10 or 100 or 1,000 or a million or a trillion. Realistically, when you multiply by 100, what happens to the number? You add 2 zeros, or you move a decimal 2 places to the right. Okay? So scientific notation is all about counting up decimal places and moving them a number of spaces and using a power of 10 to represent how many spaces we've moved the decimal point in which direction we've moved it. It's really all scientific notation is. And we use it so we don't have to write out. And 250,000, that's not a really big number. But what about our national debt? Which is in the what? Trillions. Go ahead, take the time to write out a trillion on your sheet of paper. Think about it. What's a trillion? 1 trillion. What does it look like? Okay. This puts me in the what? This puts me in the thousands. This puts me in the millions. This puts me in the what? Billions.
Oh my gosh. We broke.
There's a trillion.
We are so broke.
Okay, yeah, it is. It's exceptionally high. But think about it for a minute. Why do you think that they say trillion instead of writing it out this way? Yeah, and most people don't even know how to read the number if they see it that way. But I'm going to be honest with you. Which is more shocking? When you see 3 trillion or if you saw this number? Okay? I think the American public actually needs to see 3 trillion written out this way. My salary's in that category. Are you ready? 10 years, my salary's there. 10 years, my salary moves here. After 20 years, right, you'd multiply by another 10, I'd be here. 10, 20, 30, 40, 50, 60, 70. I physically have to work for 80 more years to even come close to the national debt. And it doesn't even work that way. I mean, I use simple numbers, and that would assume that my wages were going to increase and the national debt was not going to do what? That concludes nothing, guys, nothing. The people of our nation need to see trillions written this way once in a while instead of the word trillion, so that we understand it. But in the scientific world, we don't write things this way. We found a shorter way to write things when they have a lot of zeros behind the decimal point or even in front of the decimal point, when you're working with extremely large numbers or extremely small numbers. And it merely is amount of counting. So it says on 250,000, you're going to move the decimal point to the left as many places as necessary to find a number that's greater than 1 or less than 10. Where do I want the decimal point to be in 250,000 if the number in front of the decimal has to be greater than 1 but less than 10? Clear. in between the 2 and the 5. This is where the decimal wants to be. Okay? The number in front of the decimal then would be 2. Greater than, it's 1, so it's between 1 and it's less than 10. Okay? Now, with that being said, it says, what number did we find? We found what?
2.5.
Okay. It says divide 250,000 by your answer. So go ahead, get a calculator out.
Don't you dare say it, Dylan.
It says, but write your answer as a power of what? 100,000 would be 10 times what?
4.
So what power? 10 times 10 times 10 times 10 times 10. It's basically like counting zeros there, right?
Yes, sir.
So, 250,000 would be the same as 2.5 times 10 to the 5th power. Now, they're showing you how to break it down. Do you think we take the time to do that? What do? We count decimal places. That's 3, 4, 5. I count 5 places. So it's going to be 2.5 times 10 to the 5th power. That's all we're doing. 41,200. What am I going to put in the little box? 4.12. And how many places am I going to move the decimal?
4.
There's 3, and there's 1 more. 4 places. 10 to the 4th power. Hard?
No.
Pretty easy?
Yeah.
We all good? So, let's look at the year terms. What am I gonna write here?
6.4.
Times
10 to the 3rd power.
10 to the 3rd power. Because I'm going to have to move the decimal 3 places.
Oh my goodness, look at that number.
Okay?
I get it.
Number 4. What am I going to write?
5.7.
5.7 times
11
3, 6, 9, 10, 11.
I have a question. So you went all the way to
Right here. I count all the way to there. Where's the decimal on this number implied to be? It's implied to be where? At the end. How far did I have to move it? Well, I'm counting commas at this point. Because commas means how many places? 3. So there's 3, there's 6, there's 9, plus 1, 2 more. 11 places to get it between the 5 and the 7. Okay? So 5.7 times 10 to the 11. 9.461 times 10 to the
12 power.
12. 3, 6, 9, 12. Okay? By the way, which is going to be easier to work with later on if I have to work with it? This or this one with all the zeros? The bottom one is going to be much easier to work with, and later this week we're going to talk about how we add, subtract, multiply, and divide using scientific notation. That seems like it's hard, but what it does is it goes back and uses our rules for powers of 10, and you're going to find out that it's very easy to work with it once it's in this form. Okay? Are you okay so far?
Yes, sir.
We also need to know how to go the other direction. How do we get something that's in scientific notation back to standard notation? I'm not necessarily going to add that many zeros, but I am going to move the decimal that many places. I'm going to move the decimal to the right if that's a positive number. How many places?
9 times.
9 times. So, 7, 1, 2, 3. I've moved it 3 places already, right? How many more places do I need to move it? 6. So how many zeros am I going to add?
6.
And do yourself a favor. When you're done, put the commas in your answer so that it's easier to look at and see whether it's right or not. On number 9, how many places am I going to move the decimal? 5. 2, 3, 6. How many places have I moved it so far? I've moved it 2. How many more places do I need to move it?
3.
Are you still okay? On 5 times 10 to the 6th, where's the decimal point? It's behind the 5. Okay? That's where it is. How many places do I need to move it? 6. So what am I going to end up adding?
6 zeros.
I agree. Can you count?
Yeah.
If you can count, putting things in scientific notation is easy. Understand, in scientific notation, the number in front of the decimal has to be between 1 and 9. Less than 10 equal to 1. So if I ask this question, is that in scientific notation? What's your answer?
No.
No, it's not. What would it be in scientific notation? Does anybody know?
2.348.
Times 10 to the what power?
4.
4, because I had to move it 1 more place. I got to add that decimal place back in.
Would that be on
Okay. You're going to see it when we start talking about addition and subtraction. Okay, we're going to practice moving that decimal point so that the powers of 10 are the same when we add and subtract. Multiplication and division doesn't matter. It's almost like working with fractions. When you're multiplying and dividing, do they have to have a common denominator? No. But if you're adding and subtracting, what do they have to have? A common denominator. When you're adding and subtracting scientific notation, the power 10 has to be the same because it lines up the decimal point. To make sure that the decimal points are lined up when you're adding and subtracting. I can't add and subtract 2 numbers if the decimals aren't lined up, can I? What's the first thing I got to do? I've got to line them up. That's what the power of 10 does for us. It lines up our decimals. Okay? Now, if you flip back a page, you're going to see these on the reflect. And I want to talk about these just real quick. Is it on the same page? Okay. I just knew it was further back. These 2 reflect questions. Explain why the exponent, 3.5 times 10 to the 6, is 6, while there are only 5 zeros in 3,500,000. Blair. Very good. Because the 5 replaces one of the zeros. 5 takes up one of those places. Okay? The next one's a little bit trickier. What is the exponent on 10 when you write 5.3 in scientific notation? If all I want to do is write 5.3 in scientific notation, what is the exponent on this 10?
1.
Where?
0.
David, can you tell me why it's 0?
Because the exponent, the a exponent by 0 is 1.
Right. Because anything to the 0 power is what? 1. What's 5.3 times 1? 5.3. Everybody see that? So, I can write 5.3 in scientific notation. Is that a number we would typically write in scientific notation? No. Why? Anybody know that? What do we write in scientific notation? Started the lesson this way. Very big or very small numbers. Does 5.3 fit either one of those categories? No, not really. So we typically wouldn't write it that way. But it is important to recognize that we could. And if I write to the 0 power, this is the same as 1. And I can see that 5.3 times 1 is still 5.3. When you're multiplying by that power of 10, it's simply moving that decimal point the number of places it needs to move. Did it need to move in this case? In fact, how many places did it need to move? 0 places. Everybody see the connection? We all good?